So good evening all. In the last class we have discussed that is the resistance firing and resistance capacitance firing. So UJT firing circuit. Before going to the UJT firing circuit, we will see the UJT construction. So UJT construction we have studied so in third semester. Okay, if you have remembered, it's fine. So I will just brief about the UJT construction. UJT consists of three terminals. Okay, so emitter, the base terminals, two base terminals B2 and B1. You can see we will be having a single PN junction. So this emitter terminal is closer to the base 2 compared to the base 1. So and we have a that is a voltage VBB between the two bases. Okay, so this is going to be a base contacts and this is only a single junction, that is a PN junction we have. That's why it is called a unit junction. So transistor. Though this is the symbol of this, you can see. So I have shared the written notes in the Google Classroom. You can refer that. So the symbol consisting of that is emitter, base 2 and base 1, and arrow it is indicating the direction of that is a conventional current. And equivalent circuit also you can see. So in the emitter part we have connected that is a diode. And so we have two resistances. RB is going to be variable. So that is it is going to be some 0.5 kilo ohm to 5 kilo ohms according to that, and IE is going to be varied. So next, this is the equivalent circuit of this. You can see that is will be having a that is intrinsic standoff ratio zeta. So zeta is going to be RB1 divided by RB1 plus RB2. This is also is equal to RB1 divided by RBB. That is the summation of two resistances RB1 and RB2. We are going to call as RB. So this is emitter base resistance of the between the terminals of the device, between the terminals base 2 and base 1. So this the equivalent circuit you can see we will be having RE and VEE. So that is going to combine, that is a VE is equal to IE into RE. So we have a diode at the emitter terminal and it is connected to the junctions of a two resistors RP1 and RB2, and we have applied the base that is the supply voltage VBB between the two. When IE is equal to 0, when IE is equal to 0, so when IE is equal to 0, when IE is equal to 0, so it is going to be so, and VE is equal to VE and UJT is going to be in off state when VE is equal to the value voltage, and IE is going to be greater than 0 and it is going to be in an on state. So now we will see that as the characteristics of UJT. So characteristic of UJT you can see here. So this is when V is going to be equal to the VP and UJT will be entering into the on state. So and when VE that is going to be reached as say VP, that is a value voltage and value current. So peak voltage and a peak current VP. So that is IP indicating value, that is a peak voltage and a peak current. IV and VV indicating the value voltage and the value current. So that is, so it is mentioned. So that is a cutoff region, saturation region, as well as negative resistance region. So negative resistance region is a stable region and this is going to be active region of the UJT, and most of the applications are going to be happening this in this region only. So why it is called a negative resistance region? Okay, so negative resistance region, if you write this is a resistance formula, that is V, that is R is equal to V by I. So that is, so what is voltage is decreasing. So voltage is decreasing means your resistance is also decreasing. Negative resistance means we are not going to get any negative resistance in this region. That is voltage is decreasing means your resistance is also decreasing. The decreasing of this resistance we are just calling as a negative resistance region. So you can see here when V is equal to VP, the UJT enters into the conduction state, and when that V is equal to the value voltage, so it is going to some minimum voltage it is so entering the, again the V is going to be so you can see after IV, so again IV started increasing, so that is UJT is entering to the saturation. That is UJT as a relaxation oscillator. We know the oscillator without giving any AC signal, we are able to generate. So that is oscillations. So here using UJT, we are able to generate. So that is we are able to generate pulses. That is those pulses I will be using to drive the that is a gate terminal of a SCR. So that SCR is going to be turned on. So here you can see that is so initially so when you are going to give that is the VBB to the circuit. The DC voltage what you are giving to the circuit is going to be so VBB is given to the circuit capacitance. So when V is equal to V, UJT is going to be turned on. Okay. So when UJT is going to be turned on. When UJT is turned on, the capacitor voltage is discharging. So when the capacitor voltage, so that reaches a VE minimum, okay, VE minimum. So then, so and okay, we started charging. So this is the charging period of the capacitor. Okay, you can see this is the charging period of the capacitor. So when the capacitor started charging, so that time capacitor will be started charging. You can just observe here. So this portion of the waveform, that this portion of the circuit. So this is the portion of the circuit that is UJT is going to work as an oscillator. So this oscillator we are going to call as a relaxation oscillator. So that here I am going to give VBB. So voltage VBB will be given. So when VBB is given, okay, so when VBB is given to the circuit and capacitor will be started charging. Okay, so capacitor will be started charging. So when V is equal to VP, so that time capacitor will be started discharging. So when capacitor started discharging, so that time UJT is going to be turned on. Initially UJT is in a off state. When you are going to give VBB, capacitor will be charging through a resistor R. When emitter voltage equals to Vp, so that time capacitor will be started discharging. When capacitor started discharging and UJT is going to be turned on. So UJT is turned on, and so when capacitor voltage so reaches a VE minimum, that is a so emitter voltage reaches a VE minimum voltage somewhere here, it is going to be a VE minimum voltage. Okay, so when it reaches a VE minimum voltage again, so your UJT is going to be turned off and the capacitor will be started charging. So in this way I'm going to get charging and discharging and charging and discharging. When capacitor is discharging, the UJT is going to be turned on, and this is the that is the time period the UJT is going to be turned on. In this time period I'm going to generate, that is the pulses are going to be so generated. Okay, so that is when VBB is given to the circuit, initially the UJT is going to be turned off, it is turned off. when VBB is given, capacitor is started charging through a resistor R. So when VE is equal to VP, capacitor will be started discharging. That time UJT is going to be turned on. When UJT is turned on, the emitter voltage or discharging voltage reaches a VE minimum voltage. That time again UJT is going to be turned off. The time period so for which the discharging of the capacitor is taking place, that time the UJT is turned on. So that time we are able to that will generate a pulses. So that is going to generate a pulses at the base terminal of the that is the B1 terminal of the this. So this is going to be a UJT oscillator. When so the base B1 is able to generate a that is a VB1 is going to be what? So that is VB1 is going to be a pulses we are going to get. So that is wherever the UJT is going to be on, so there we are able to get a that is the pulses from the UJT oscillator. Now this UJT oscillator, that is UJT as a gate trigger source, that is a gate triggering circuit. You can see the UJT. This is a relaxation oscillator. So that is UJT relaxation oscillator that is given to the gate terminal that is generating a pulses that is given to the gate. So that is given to the gate 1 kilo ohm. And we have the load resistor at the anode side, and we are going to give a the supply voltage of 28 volts. So now, so that is UJT oscillator generating a pulses at the terminal of B1. So then it is given to the gate terminal of the SCR. So now SCR is going to be turned on. Okay, so this is the way we are going to turn on the SCR from the UJT. This is what that is a UJT triggering circuit. So next we will see another circuit. So this is a synchronized UJT triggering. So it is also called the ramp triggering. So here in this circuit you can see, so this is what we are having, that is a D1 to D4. It is going to be a rectifier. We know this rectifier is going to be a giving or converting the AC voltage into a DC voltage. The EDC what you are getting here, and so this RS we are connecting here in order to give a that is a desired or certain or lower values to this Xeno diode as well as the UJT. This RS we are connected, so that is in series with this rectifier in order to give you the suitable voltages or suitable values or lower values to this Xeno diode as well as UJT. Okay, so now this Xeno diode, why I'm using this? So we know the clipping, right? Clippers we know. So this EDC is there. So this is going to be, so what is the output of the rectifier? What is the output of the rectifier? Anyone? So write in chat or you can unmute and you can answer. So rectifier output is what? It is a DC. What kind of DC we are getting? I am going to give a sine wave as the input signal. What is the output voltage? It is a full wave rectifier. So you can write in chat also. So what is the output of the rectifier? What is the output of the rectifier? You don't know? You are not done the rectifier experiment in third semester then. Yes, you don't know the rectifier and you have not done any experiment also. Bridge you not done, center top you have not done, and after your rectifier also you have not done even your third semester. So what is the output? What is EDC here? So this is a sine wave I'm going to give, and for this sine wave that is AC signal input. So what is EDC? Anyone? You don't know. You don't know the basic rectifier output, you don't know? just it converts AC to DC. So can you able to write the waveform, or can you able to tell what is EDC? It is a DC voltage. So what is that? So 40 members are there. In the 14 members, no one knows. Yes. So output of this rectifier is going to be what? Pulsating DC. So pulsating DC, I'm going to get like this. That is a full wave rectifier. So for this pulsating DC, I'm using the Zener diode. I have to clip out the peak part of this EDC. This is going to be what? EDC. So Zener diode I'm using here. I have to clip out this. So I will clip out these parts of this. So Zener diode is used here to clip out the peak of these signals. Now I'm going to get only this portion. This is going to be a VZ. So now I am, so this VZ output voltage, now I'm applying to the RC circuit. Here R is variable. So now when VZ is applied and capacitor will be charging here somewhere like this. It will be charging and discharging. Okay, I will write neatly. So this is going to be the pulsating DC, and I am using VZ here. So in order to clip out the peak parts of the signals, so I will be having, okay. So when VZ is applied to the RC circuit, so capacitor will be started charging, and I am going to get charging and discharging, charging and discharging, charging and discharging of a capacitor like this. So we know this from the, that is, so this is RC circuit that is connected to the what? UJT. Okay. So now when capacitor is charging, UJT is in a off state. When capacitor is discharging, so UJT is going to be on state. So just I will take only the on state. So just I will take only the on state of this, on state of this, and on state of this, and on state of this, like this. And so okay, so now when capacitor is charging, UJT is turned off. When this capacitor voltage or emitter voltage become equals to the peak voltage, so UJT will be entering into the on state and capacitor will be discharging. When the capacitor is discharging, that time UJT is turned on. Again, when this emitter voltage reaches a certain minimum value, so that time again, that is UJT is entering into the off state. So this process is going to be repeating, charging and discharging, the turning off and turn on of a UJT. When the UJT is turned on, so that time, so that is, this circuit is going to generate pulses. So pulses will be generated, and these pulses we are, so that is, the capacitor is discharging through a emitter and primary winding of this pulse transformer, and at the secondary windings, so we will be having these pulses. So we have seen, so when UJT was working as a oscillator, it is able to generate pulses, and those pulses we can give the gate terminal of the SCR to turn on the SCR. Here we have given a AC signal that we converted into a DC, pulsating DC. Again in that we have clipped up the peak values, that is a VZ, that is applied to the RC circuit of the UJT. When, so for the charging period of the capacitor, UJT is in a off state. For the discharging period of the capacitor, UJT is in a on state. So that is UJT is, that is a capacitor here discharging through a emitter as well as a primary winding of the transformer, and from the, at the secondary windings, so we are able to generate the or we are able to get the pulses. So these pulses now able to so can give the gate terminal of the SCR. So here we can turn on more than one SCRs, that is the pulses what it is available at the secondary of the transformer. So these can be applied to the more than one SCR gate terminal, so that we can turn on more than one SCRs. Okay, so this is what, so the synchronized UJT triggering okay circuit. So that is I will just show the what so it is there, that is the waveform is not there in this. I think this is the last, this is you can see the waveforms, that is a EDC, the pulsating DC what we got. And so this is a VZ voltage, and this is the level eta into VZ, and the VC, that is a charging and discharging. So in the discharging path the UJT is turned on. So and we are able to, that is the voltage pulses are available at the secondary of the transformer. Okay, so using these pulses we are able to turn on more than one SCR. So this all the going to finish, that is a module 2 SCR. I will just take up some problems in UJT. You can see here, so the problem is, that is if RE is equal to 1 kilo ohm and valley current is 5 milliampere, determine the value of VE which will cause UJT to turned off. Okay, so the V is equal to value voltage 2 volts, that the value, that is it is taken from the characteristics, and IE is equal to IV 5 milliamperes. So applying a KVL at the input side, that is the input side is consisting of what? So input side is going to be consisting of RE, that is a VE, and so here it is going to be the emitter terminal. Okay, so this is RE and VE, and we will be having so VE here. Okay, you can see the input part of the circuit. So applying a KVL for the input part of the circuit, it is going to be VE is equal to IERE plus VE. So IERE, that is multiplication of 5 milliampere into 1 kilo ohm, I will get a 5 volts, plus V is going to be a 2 volts, 5 plus 2 it is going to be a 7 volts. So this is the UJT to be in a off state. So next is going to be a, so that is a UJT. So you have to design UJT relaxation oscillator using, that is UJT number they are given for triggering an SCR. So UJT have the following specification. They are given intrinsic standoff ratio, the peak values, value voltage, current, VBB 20 volts, RBB 7 kilo ohms, and IE0 2 milliamperes. We also determine the output frequency of the oscillator. So solution we are going to assume, that is because T is equal to RC into ln of 1 divided by 1 minus zeta. So that two unknowns are there. So that's why we are assuming C is equal to 0.1 microampere. So then, so we have to determine, that is what is the maximum value. At the peak values, we are taking the maximum values. At the value point, we are taking a minimum values. So R is equal to V by I. So that is a peak voltage divided by peak current. We are going to calculate R max, that we got 120 kilo ohms, and using R minimum is equal to the value voltage divided by the value current, we got R minimum 3 kilo ohms, and the calculation of R2 we have taken 10 to the power of 4 divided by, so that is so intrinsic standoff ratio into VBB. So this value we are going to calculate. So next, so this value is going to be so 714.29 ohms. So next you can see calculation of R1. Calculation of R1 is going to be minimum I. So G is 0.2 volt, and calculate R1 is going to be ohms. Next using Okay, so here the frequency is equal to 1 by T. You know that formula, and we will be having the voltage across the capacitor is given by Vp is equal to VBB into 1 minus e to the power of minus T by RC using transient analysis. So next, so capacitor discharge through R1, Vp is equal to intrinsic standoff ratio into VBB plus VD, that is not V naught. So we have two equations for Vp, equating those two equations and neglecting Vd. Okay, so I'm going to get intrinsic standoff ratio. So this is equal to intrinsic standoff ratio into VBB is equal to VBB into 1 minus e to the power of minus T divided by RC. So VBB will get cancelled, and I will take that is 1 r zeta that side. So it is going to be e to the power of minus T by RC 1 minus eta. So then that is a minus is there, I will remove the minus, then I will be having so e to the power of T by RC divided by 1 divided by 1 minus eta. So then taking a log, it becomes T divided by RC is equal to log of 1 divided by 1 minus eta. So then T is going to be RC into log of that is 1 divided by 1 minus eta. So when we are going to substitute T is equal to T, so that is going to become T is equal to RC ln of 1 divided by 1 minus eta. So this is the time period of the oscillations of the UJT, that is UJT oscillator. So frequency we know 1 by T. So I'm going to get frequency expression F is equal to 1 divided by RC log of 1 divided by 1 minus eta. Okay, so these kind of problems they can ask. So to designing of relaxation oscillator, so that is going to trigger the SCR, or that is a derivation of this time period or frequency of the UJT relaxation oscillator. So this finishes the module 2. So next I will start with the module 5. So that is SMPS, some relays are there. So that portion I will start. The first part of this will be starting by Prashant sir. So the off of in the module 5, that is off will be covered by Prashant sir, and another off will be covered by myself. Okay, if you have any doubt you can ask, otherwise so that is time is okay. So that is whatever the documents I shared in the Google Classroom, that is written notes and a textbook copy, as well as also PPT. You referred those things, and so UJT, that is UJT working as an oscillator, its equivalent circuit and its construction and its characteristics you studied in third semester. You have to remember those concepts, and now you can understand easily those concepts. So that is UJT is generating pulses. Those pulses we are giving to the gate terminal of the SCR, and SCR is going to be turned on. So this is the concept. So that is UJT triggering. So I will end in the class. So next class I will start with the module 5.